Hello everyone in SCR 215. This is Group 5 and we are here to present our project. And we decided to do a digital rendition of the popular board game Connect 4. And as you can see in front of you, this is an original picture of the popular board game by Hasbro Gaming. Alright, and just a fun little side note, the game actually used to be called The Captain's Mistress, and you can think of multiple reasons why it was called that. Alright, so what we wanted to do, so we wanted to develop a single player Connect 4 game, and then the player would be playing against a computer AI. And then we will allow the player to make the moves, and then the computer will automatically make a move, and then the program itself will determine a winner or if it is a tie. Okay, so after clicking on the jar file or running the game, the user will be introduced with a menu, and then from that menu, the user can decide square grid of 7 by 6 or 14 by 12. And what I mean by square grid is that it will have multiple holes. It will be a blue background with plain holes, like just round circles in between them. And then these holes will be filled by either a red or a yellow chip. And it'll look something like this. It's a red chip. So blue background with the grid with either 14 by 12 or 7 by 6 grid with round holes, and then you have the red and yellow chips. All right. Okay, so what would the rules be, and how would you determine a winner? So in order to play Connect 4, let's say I wanted to insert a yellow chip into this column. Well, I would click above in this, I would click this column, and then the yellow chip will fall all the way down here. But let's say I wanted to insert a yellow chip in this column. It would fall over here since there's already 3 red chips over here. Okay, hope that makes sense. And if the column is full, then you cannot insert any more chips. All right, and in order to determine a winner, you either have to get 4 dots in a row, horizontally, vertically, or diagonally. And these 4 dots in a row, they cannot be interrupted. So let's say, let's imagine you have 2 yellow dots right here, and then another yellow right here. Well, that would be 4 in a row, but not really. You have this red dot right here, so it would be broken up. So they have to be exactly in a row, unbroken. Let's say we had inserted a red piece right here, then red would win right here. All right, cool. All right, so this is our use case diagram. So we have the player. The player starts the game, and then the controller will just say, okay, I'll show you the GUI from the menu. The player chooses the type of grid he wants, and then we'll begin playing, and the controller will call on the AI to play against the player, and the GUI will get responses from the player, and the controller will process those commands and either display something in the GUI or contact the AI again. All right, so this is our class diagram, and so we have our board, and the board, we wanted the board to be the backend, so then it would have algorithms for checking, what either like for like wins or ties, it would be like it would check the whole board for horizontal or diagonal or vertical wins. And then we have the AI, and we have the GUI, and the GUI would obviously have the listeners, and that would take in commands from the player. Yeah. Okay, so let me show you guys the game then. All right, so here it is. All right, so we got the blue board with the grid, and as you notice, we didn't have a menu because we decided to just go with a 7 by 6 board, and just to keep things just much more simpler and easier to implement. So it's just 7 by 6, and and this is the board, and these are actually the buttons. So this top right here isn't considered part of the board. So these are all JButtons. We use Java Swing to develop this. So they're all red now, indicating that this is the red player's turn. So I'm just going to click this middle guy right here, and as you can see, red drops down. Great. And unfortunately, we just decided to go with black instead of yellow just because, I don't know, black and red, they just look much better together than red and yellow. All right, so I'm gonna click the middle again, and it should drop on top of the red. Yep, and it does. Okay, and I'm just gonna play a quick game to show you guys um, red winning right now. All right, ta-da! Red wins, and and then the game will ask, "Do you want to play again?" And we will click yes. And as you can see, it is the black player's turn. And let me show you guys a tie real quick. Just give me a few seconds. I actually memorized this whole thing just to for this presentation. Like I memorized all the moves just to show you guys a tie. Yep. So as you can see, there's a tie because we have no four in a rows, no diagonals, no verticals, no horizontals, and the game is working properly. All right. Yes. And you're probably wondering where is the AI? Well, unfortunately, we couldn't create the algorithm, a proper algorithm for the AI. We were able to create a simple AI, just one that would click the middle button all the time. But then obviously that's not a very challenging AI, and we couldn't. So basically, we couldn't make one that was smarter than or as smart as an average human being, and then it just wouldn't make the game fun at all. So we just decided to go with a two-player game. We were close though, if anyone wants to try this, I would recommend Googling Connect Four algorithm, and the first one there's a MIT presentation on it, which is pretty good. We got pretty close, but couldn't quite get it right. But yeah, thank you for watching, and hope you guys like our game.